Hi there. So in this video we're going to see how to publish your Matlab code in HTML format. So let's first create one plot, let's say bar plot, and I'm going to create one array with value 1 2 3, then 4 5 6, then I have another array with the value 4 5 6 7 8 11. Then I have this bar function that takes x and y as arguments. Okay, and let's execute this and find out how to properly export this graph into HTML. For this, let's say I'm going to go to command window, and here I'm going to use a function named publish, and I'm going to pass sample.m as my file name. Okay, I'm already in a path where I can access this sample.m. If you are on different directory structure, then you have to type that path up to this file. Okay, next thing, export to HTML, so make sure that it is in single quote as well. Now simply execute this and you will have one figure exported, and you have to navigate to that directory. Okay, and I am in that HTML folder. I can click on this and I can find out whether my exported graph looks exactly the same in HTML page or not. Now I clicked on it, and as you can see, it shows my code in sample m as well as the graph that it generated. Also at the bottom it shows the version of Matlab being used. Okay, so you get the idea of how to export your code and the respective results from your editor to HTML. Hi there. So in this video we're going to see a random number generator in Matlab. So we are going to take a look at three functions. First is ran function, then ran n function, and then ran I function. So let's take a look at our first function, which is ran. Okay, so first thing I'm gonna do is let's create one variable, then assign a ran function to it and make it have a number, let's say 5, and this should create 5 by 5 matrix which has uniformly distributed random numbers. Okay, so the function ran will have random numbers which are uniformly distributed. Okay, so let me display the values from R using this function. If we use run button, then it should show us in our command window as 5 by 5 matrix with uniformly distributed random numbers. Now the next function that I want to discuss is rand n function. So this function will have values which are normally distributed random numbers. So let's start with variable r equals to rand and then n, and within our function we give it 5. Okay, then in display method we use r. Okay, so this r will have 5 by 5 matrix of random numbers which are normally distributed. Okay, so let's run this and see how it works. So you get the idea of the 5 by 5 matrix that contains normally distributed random numbers. Now the third function is randi function. In this function we use uniformly distributed pseudo-random integer values. So let's start with creating our variable r, then passing it randi function that contains our value maximum 10 and total 5 by 5 matrix with uniform distribution. Okay, then we use display method, pass this variable, and we will have our 5 by 5 matrix with uniformly distributed pseudo-random integer values. Okay, so you get integer values here. As you can see, there are no floats like we had in our previous two functions. Okay, so these are uniformly distributed pseudo-random integer values. So each of these function can be used when you want to populate some table or array with random data. Hi there, so in this video we are going to take a look at size and shape operators in Matlab. So we are going to open text editor and going to first try length of vector. So let's create one vector, let's name it b, and I'm going to add values such as 1 2 3 4, and then we are going to simply display the length using length function and then pass on our vector to it. Okay, so let me run this and see what happens, and we get the output as 4, which is basically because the number of elements in our vector are 4. Now what if I want to know the size of matrix? Okay, so let's create one matrix, let's name it A, then in first column we have 1, then 2, and then in next row we add 3 and 4. Again we have 2 rows, 2 columns. Okay, now I'm gonna find out size of this matrix A. So let me use display function and then simply end it with semicolon. Now if I run this, I get 2 rows and 2 columns as a size. Okay, next thing is reshaping the matrix. So let's use A equals to 1, then 2, and then 3 and 4. Okay, and after that I'm gonna reshape this to, let's say, A, and then I can specify number of rows I want is 4, and I want to keep column 1, whereas I have 2 columns and 2 rows. I want to change that into 4 rows and 1 column. Okay, so let me just change this. Okay, and let's display the output with reshape. So if I run this, I get 4 rows and 1 column. Okay, so we check length of vector, size of matrix, reshaping the matrix, and finally finding the dimension. Okay, so let's find that out. I have created one more matrix, 5 6, and then 7 8. Okay, and then here I'm going to use n dims, and here I'm going to pass my matrix right here. So if I use display function and print that, and it should show me number of dimensions my current matrix has, and it says 2. Okay, what if we change this A to B, and let's see if I add one more dimension, and let's try and calculate, and if I run this, I get again 2. Why? Because we are keeping our rows and column constant. Okay, so you get the idea that how to find out length of vector, then size of matrix, and also shape of matrix and dimension of matrix. Hi there, so in this video we're going to see how to sort, reshape, and circular shift arrays in Matlab. So let's start with our first example of sorting an array. So first thing, let's create one. I'm going to add some data here. So let's say I have this data in my array and I want to sort this. So I'm going to use sort, and this function will take your array name, and when you execute this, it should sort the elements within your array. So let's run this, and sorry, I have to display the above output. Okay, so let's run that, and here you see the element here is sorted in ascending order. Okay, now if you want to display this in descending order, then we can do another example. Let's say I have one more array, and we're gonna make it look like something like this. Okay, let's have it in matrix form, and we have this. Okay, now I want to sort this. So for sort, let's use our sort function, then pass our matrix, and then dimension is one dimension, then order or mode is descent. Okay, and it should be in single quote, and once you do that, you can also include this in display function, and let's just save this. Okay, now if I execute this, it should show me sorting in descending order. As you can see, for each column it shows you in descending order. Okay, this was for sorting your array. Now let's see how to reshape it. Okay, let me just clear the command window. Now for sorting, let's create one matrix. Let's make it 4 by 4. Then okay, then let's add 2 4 6. Okay, now here I want to reshape this, so I'm going to use a reshape method, and I'm going to pass my matrix and reshape, let's say from 2 to 6. Okay, so this method will take total 3 arguments in this case, and you'll be able to display your new reshaped matrix, okay, in B. So let's run this, and as you can see, you get your B as 2 by 6 matrix, whereas you have this 3 by 4, and that is now reshaped into 2 by 6. Okay, so this was a reshape example. Now there is one more case, which is circular shifting. So let's say I want to circularly shift first dimension values down by 1. Okay, so we can take a look at that as well. Let's just say I have this matrix here, which is 1, then 2, then 3, and then in the next column 4 and 5 and 6, and then 7, and then 8, and then 9. Okay, and when I use this circular shifting, I use B circular shift, and here I use my A, and then shift size I have to mention. So let's say I want to circular shift first dimension value down by 1, so I'm going to use 1 and colon, and then simply use this method and pass my B for the output. Okay, let me clear the window. Okay, now let's run this, and you get the output for circular shift. You get 7 8 9, and then for next we get 1 2 3, and then 4 by 6. Okay, these are done through each column respectively, so you will find that your 1 goes 1 step down, whereas 4 goes 1 step down, and 7 goes at the top. Same for rest of the columns. Okay, so what we have seen is sort, reshape, and circular shift for arrays in Matlab. Hi there, so in this video we're going to find out square root functions in Matlab. So there are two functions that I want to show you. One is sqrt, which is used for your typical numbers and the real and imaginary pairs, as well as in case of real sqrt function, here you can find out square root for non-negative real arrays. So let's start with sqrt method, which should take 64, and when you hit enter it should give you 8. Okay, now similarly you can also use simple range from, let's say, -2 to 2, and trying to find out your imaginary and a real number square root. Okay, and you get square root for this range. Now if you want to find out square root for real non-negative array, then simply use, let's say, your magic method that can find out all real number for 4 by 4 matrix. You can use that and simply call for real sqrt and simply pass your magic array generated. Okay, and here you find out real square root for your array here. Okay, so you get the idea how to use sqrt function and real sqrt function. Okay, these two functions can be handy for finding out square root of your real as well as imaginary number. Hi there, so in this video we're going to see switch case in Matlab. So I have created this new script in Matlab and here I'm going to write the code. So inside that I'm going to set option to 2 and in switch function I'm going to point to this option. Okay, and inside this I'm going to say case 1 and I want to display, let's say this is 1. Okay, and after that I want to have my second case, case 2, and here I want to display case 2 here. Okay, and after that let's say I have one more case and I want to display message case 3 here. Okay, and finally I want to end my switch, so I use end keyword. Okay, now our program should directly go to this display option case 2 here and it should end. Okay, so what happens in switch is that it looks for the available option from within our case. Okay, you don't have to choose only number, you can also use some character as well. So instead of 1 to 3 you can change this to A, B, C as well. Make sure to have it in a single quote however. Okay, so let's try this and see how our switch case works. And as you can see in command window it prints out case 2 here. So that was short introduction to switch case in Matlab. Hi there, so in this video we're going to take a look at symbolic math functions in Matlab. So we'll take a look at expand function, simplify function, tailor command, and pretty symbolic function. Okay, so let's start with our first expand function. For that we have to first call sims and then the variable that we want to use. So let's say x, and I have equation f1 and inside the bracket x plus 5 multiplied by in bracket x plus 5. Okay, and now I want to display this output of expand function. Okay, and if I run this then it should show me how my equation is expanded into a formula doing basic symbolic math. Okay, and you get the idea, x squared plus 10x plus 25 is how my formula is expanded. Okay, so you can change this if you want. You can simply change the values x plus 3 plus x plus 5 and see you get different output. Okay, so you get the idea of how to expand any of your formula by simply using this expand function. Okay, now next thing is simplify function. Okay, so for simplify let's use one equation. Let's say sine of x and then raised to 2. Okay, now if we do addition with, let's say, cos of x raised to 2, we can simplify this using simplify and then closing this, and then use display function. And if you close this, and now if I run this, I get simplification of my sin x square plus cos x square formula. Okay, and it gives me output as 1. Okay, now there is one more function which is pretty function, so it will also do similar work. So instead of simplify, if I use pretty, then it will try to prettify this function given. So let's run this, and you can get that it will flag the error too many output arguments. Okay, so let me just remove my display function and then try to execute this. And as you can see, with pretty function we don't need to use display function. The reason being, pretty function itself will output our formula, and as you can see, we don't have to use raised to power for a square or cube. Pretty function will do that for us. So we use cos x square plus sin x square, and it is prettify with this pretty function. Okay, your formula can be as complex as it can, and it will try to simplify and then show it in pretty method on your command window. Okay, now similarly there is one more thing that I want to show you is Taylor command. Okay, so let's use formula f equals to Taylor, and here inside I have log of 1 plus x. Okay, then I use display of f, then let's see what it outputs. Okay, let me just clear the command window so that it can show me proper output. Now if I run this, it shows me the Taylor series due to Taylor command, and I get x raised to 5 by 5 minus x raised to 4 by 4 and so on up to value of x. Okay, now what we look so far is expand function, simplify function, then pretty symbolic function, then finally Taylor series command. Okay, so this was a simple introduction on some of the symbolic math functions in Matlab. Hi there, so in this video we are going to take a look at symbolic math operation in Matlab. So we'll take a look at comparison of using some of the standard math functions versus the symbolic math functions that we are going to use. So first let's find out square root of, let's say, 2, and for that we will use display function, and inside which sqrt, and to the bracket we pass 2. Then we will display sim, and here we make use of sqrt. Okay, so then pass 2. Okay, so we will find out the output of these two. You will find that square root of 2 as opposed to symbolic square root of 2 would be different. Okay, so let's just check that. Okay, so when you check for typical square root of 2, then you will find that you have 1.4142 as an answer. However, when you do your symbolic square root of 2, then you get this equation that 2 raised to 1 by 2. Okay, and you also get this bracket. So symbolically that value is printed with the help of sim function. Okay, now we will take a look at one more thing, which is our typical, let's say, division, and we will try to do the same with sim 2 by sim 5. Okay, and then we will see how each output is different. So when you run this, you will find that instantly we get the answer 0.4. However, in case of symbolic 2 by 5, we get 2 by 5 as return value. Okay, now this is not simplified or solved, but instead it is just showing you symbolic representation of 2 by 5. Okay, in case of our typical 2 by 5 division, the output is returned with an answer. Okay, now simply if we change more into this, let's say symbolic 1 by symbolic 3, then it will try to find the answer of this equation. Okay, whereas if we do that with our typical 2 by 5 plus 1 by 3, then it will try to find the answer for this equation, and you get 0.7333, and in case of our second equation it gives us 11 by 15. Okay, so you get the idea that in symbolic math operation, it doesn't try to solve entire equation, but try to just represent the value as it is in symbolic form. Okay, so we'll take a look at some of the additional symbolic math operation with sim toolbox in next few videos.